So for day 2 of chapter 11, we are going to continue to talk about parabolas. Only today we are going to be focused on writing equations for parabolas given specific information, rather than in day 1 we were given the equations and we were identifying the given information and graphing. So today we're going to be given some information about the parabola and asked to sketch the graph and also write the equation in standard form. So for example 1, we are told that the vertex of the parabola is 0, 0, and the focus of the parabola is 0, 2. So what I like to do first is sketch that information. So plot my vertex as 0, 0, and plot my focus as 0, 2. So from that information, there's a couple things we should be able to tell. And the first one would be the difference or the distance between the vertex and the focus is our p-value. And also we should be able to say that the parabola will open upward. And the direction that the parabola opens will be really important in terms of identifying the equation. So again, because this parabola is, because the distance between the vertex and the focus is 2, that's our p-value. And again, I said it opens up because the focus is always on the interior of the parabola. So opening left and right wouldn't make sense in this case because then the focus point would not be inside the parabola shape. So again, it's going to open up, and what that should tell us then is it's going to have this general equation, which is x squared equals 4py, and that equation is the equation of a parabola when the vertex is at 0, 0. So in a couple examples from now, we'll look at when the vertex is somewhere else, but because x is being squared, that's going to tell us that we're dealing with an equation that opens up or down. And because our p-value is positive, again, it's going to open up. So all I need to do to write the actual equation is put my specific p-value, which is 2, in place of p in my equation. So I'd get x squared equals 8y, and that would be the equation in standard form of this graph, or of this parabola. Now, to finish the graph, just a couple more things I should identify and sketch. So because my p-value is 2, one thing about parabolas we should always remember is that the vertex will always be exactly in the middle of the focus and the directrix. So because the focus is 2 units above the vertex, the directrix should be 2 units below the vertex. And then the equation of that line would be y equals -2. And then, again, this parabola is going to pass through the vertex 0, 0 and open upward. All I need to do is identify how wide this parabola should be at the focus. And what we call that is our focal width. So the focal width is always going to be the absolute value of 4p. And 4p in this example is 8, which is the number in front of my y. That whole number is our value for 4p. So the focal width is going to be the absolute value of 8, which is 8. So how that translates into the graph would be, at my focus, I should go 4 units to the right and 4 units to the left, which gives me a total width of 8. And then sketch my parabola that should, again, pass through 0, 0, open upward. Focus should be on the inside of the parabola and then pass through those points there. That would give me a total width of 8 through the focus. For example 2, we are given a vertex of 0, 0 again, only instead of being given a focus point or a coordinate for the focus, we're given the equation of the directrix. So what I like to do is first put that information on the graph. So I have a vertical line through x equals -2, that's my directrix, and I have a vertex of 0, 0. From that information, there's a couple things we might be able to identify, and the first thing I like to do is think about the direction that this graph is going to open, and also think about the p-value that I'll be able to find from this information. So this graph is going to open to the right, and the reason I know that for sure is, again, if I have a vertical directrix, that means my parabola has to be going horizontally, because if I had a parabola that opened up or down, that would at some point cross this vertical line of my directrix, which shouldn't happen in a parabola. So again, it's going to open to the right or left, but I know for sure it's going to open to the right because, again, this parabola should not touch the directrix. And if I had a parabola that opened to the left, it would cross the directrix in some manner, especially if the vertex is 0, 0. So again, it's going to open to the right, which means I should be able to find my p-value also, because the p-value is the distance from the directrix to the focus, and then from the directrix to the vertex, and then also from the vertex to the focus. So in this case, my p-value is going to be either 2 or -2, But because this graph opens to the right, this should give me a positive p-value. So whenever a graph opens to the right, a positive p-value, or opens up, I have a positive p-value. If my graph opens down or left, my p-value should be negative. So I have a positive 2 for my p-value. So then my general equation in standard form for a parabola that is centered or has a vertex at 0, 0 is going to be y squared equals 4px. And then all I would need to do to find the actual equation would be put 2 in place of p. So I'd get y squared equals 8x, and there's my equation. To finish the graph, however, I would need to graph the focus and then find out how wide the parabola is at the focus, and then I'd be able to sketch my graph. So again, p is the distance from the vertex to the directrix and the vertex to the focus. So the focus should be 2 units to the right of my vertex, which is at the point 2, 0. So I have that. And then how wide the graph is at the focus we call our focal width. So in this example, the focal width would be the absolute value of 8, which is 8. So to finish this graph, I should graph a parabola that passes through 0, 0, is 8 units wide at the focus. So in this case, it would be 4 units above and 4 units below the focus. And then I should be able to sketch my parabola there. And then I can verify this equation, y squared equals 8x, gives me this graph, has a focus and directrix that are 2 units away from the vertex, that's my p-value, and then opens to the right because my p-value in this case would be positive. So for example 3, we are given that the vertex is 0, 0, the graph opens up, and then instead of being given the directrix or the focus, we're given the focal width, and we'll talk about how to use that information to find the equation and sketch this graph. So the first thing I like to do is plot my vertex, and then because this graph opens up, I can use the equation x squared equals 4py. That's my standard form equation when the parabola is centered or vertexed at 0, 0. So then in terms of finding my p-value, what I'm going to do is use the focal width information that was given to me. But before I do that, what I can say for sure is my focal width is always 4p, or the absolute value of 4p rather, and because this graph opens up, that tells me that my p-value is going to be positive. So then in terms of my 4p value, which is my focal width, in this case is going to be 3. So what I can say is the equation of this graph is actually going to be x squared equals 3y. And again, because the focal width is 3 and we're told that the graph opens up, I can say that the number in front of my y should be a positive 3 rather than a negative 3. If the graph opened down, that would be x squared equals negative 3y. Because it wouldn't affect the focal width, it would just have a direction of opening down, which should be a negative p-value. So now I have my equation, but I also want to sketch the graph here. So what I need to find is my focus and my directrix, and we already know how wide the graph should be at the focus, which is 3. But I do need to find my p-value to find my focus and directrix. So the way you do that is you'd set 4p equal to 3 in this case, which tells me my p-value should be 3/4. So what that means is, because my graph opens up, my focus should be 3/4 above my vertex, and my directrix should be 3/4 below my vertex. And now to spread my graph out a little bit, I'm actually going to count my y-axis. Every other line will be 1, because otherwise it'd be really crammed in at near the origin, which is fine in terms of the graph, but it's hard to be real accurate. So I'm going to go up 3/4 of a unit and plot a point. That's going to be my focus. And then I'm going to go down 3/4 of 1, which would be where my directrix is. It'd be the horizontal line through that line, or through that value. So my directrix is going to be y equals negative 3/4. And then my focus should be the point 0, 3/4. So then I'm already told the given information was that the focal width is 3. So I'm going to go up to my focus, and I need the width of the parabola to be total of 3, which means I should go to the right 1.5 and to the left 1.5 at the focus, and then sketch my parabola that passes through those points. So this would be the graph and the equation for this parabola based on the given information. For the next example, what we're going to be looking at is a parabola that has a vertex somewhere else, not 0, 0, and how to write the equation for that based on the given information. So first I'm given the focus of 2, negative 3, so I'm going to plot that. And we're told that the directrix is x equals 5. So because my directrix is vertical, that should tell me that my graph is going to open left or right. And because my focus is at 2, -3, I know my vertex should be somewhere between, actually exactly in the middle between my focus and my directrix. So based on the way this picture looks right now, I should be able to confidently say that this graph is going to open to the left. And the reason I say that is because the vertex has got to be halfway in between the focus and the directrix, but if this graph opened to the right, it would cross over the directrix, and then the focus point would not be inside the graph. So it's going to open to the left, which tells me I can write my general equation as y minus k quantity squared equals 4p times x minus h. And what that hk notation is when the vertex is 0, 0, and we shift it, horizontally by h units, whatever that is, and vertically by k units. That's how I would account for that in my equation. And that's very much like our function transformation unit we did earlier this year, where I can shift my graph horizontally by adding or subtracting a value from x, and shift the graph vertically by adding and subtracting a value to y. And that's what this equation is going to look like. I just need to know specifically where the x and y coordinate of the vertex are. So because the vertex should be exactly in between the focus and the directrix, that would put me at the x coordinate of 3.5, because if I'm at 2 and I need to go to 5, that's a difference of 3, so half that difference should be 1.5. So my vertex is going to be at 3.5, -3, and then I should be able to identify my p-value from that. So the p-value would be the difference between the vertex and the focus, or the vertex and the directrix, which in this case would be 1.5. Now, it's actually going to be -1.5 because my graph opens to the left. So my graph is going to open to the left, means I have a negative p-value, and the 1.5 comes from the difference between the vertex and the focus. They're 1.5 units apart. So now that I have my p-value and my x and y coordinate of my vertex, I can plug that information into my standard form equation. So I'd have y minus -3, which I'm going to write as y plus 3 quantity squared, and that just comes from the y coordinate of the vertex, equals 4 times -1.5, which is my p-value, times the quantity x minus 3.5. So I need to do a little bit of simplifying on the right-hand side, so I have y plus 3 quantity squared equals 4 times -1.5 is -6 times the quantity x minus 3.5. So that is my standard form equation for this parabola. Notice the x coordinate of the vertex comes from that x quantity, x minus 3.5 is a x value of 3.5, and y minus -3 or y plus 3 is the y coordinate of the vertex. Now to finish the graph, all I need to do is graph the focal width, or plot how wide this parabola is going to be as it opens to the left. So the focal width in this case is going to be the absolute value of 4p, which is -6, so the absolute value of -6 is 6. So my graph is going to be 6 units wide at the focus, so that's 3 units above and 3 units below the focus. And again, if I connected those 2 points I just plotted with the vertex, it would give me a parabola that opens left, and the focus again is inside the parabola, the directrix is outside the parabola, and all that information that was given is visible on the graph there. So if you're asked to graph, you should see a directrix visible, a vertex, a focus, and it should be the correct width at the focus. And you can check that my equation matches my graph if you went backwards from the equation like we did for day 1. And for the last example for today, example 4b, we are given the vertex and the directrix, and we're asked to write an equation, and we'll sketch the graph here as well. So first thing I'm going to do is plot my vertex and my directrix. So my directrix is the horizontal line y equals 7, and my vertex is at 3, 5. So in terms of which direction this graph is going to open is the next thing I like to identify, because then that basically helps me keep straight where my focus should be and where to plot that. So this graph is going to open down, and I know that this graph is going to open down because it's got to pass through that vertex, and it can't go through the directrix. It's not going to touch the directrix. The directrix is always outside, or a certain number of units away from the vertex. So in this case, I can say that my p-value's got to be 2, because the difference between the directrix and the focus, or directrix and the vertex, is 2. But in this case, it's got to be a -2 because this graph is going to open downward. So what I like to do at this point is write my general equation. So because this opens down, it's going to be x minus h quantity squared equals 4p times y minus k. And then, again, the focus would be 2 units below the vertex, because the distance between the focus and the directrix, the focus and the vertex and the directrix is both 2. So I plotted my focus there, and I'll identify the coordinates of that in a second. So all I need to do now is take the coordinates of my vertex, 3 and 5, put them in their appropriate place in the equation, and then put my p-value in the appropriate place, and I should have my equation. So I'll get x minus 3 quantity squared equals 4 times negative 2 times the quantity y minus 5. So what I want to do is multiply 4 times negative 2, which gives me negative 8. And that's my equation there. So x minus 3 quantity squared equals negative 8 times y minus 5. And all I would do now at this point is sketch the rest of the graph by finding how wide the graph is at the focus, and then I should be able to finish the graph. So the focal width is going to be the absolute value of negative 8, which is 8. And again, if I wanted, and then I should probably write the equation for the coordinates for my focus as well. So the coordinates of the focus are going to be at 3, 3 as well. So definitely want to make sure I have that visible also in my work. So now, the focal width is going to be the absolute value of negative 8, again, which is 8. So that means to the right and left of my focus, I go 4 units right, 4 units left, gives me a total width of 8. And then if I sketch the parabola that passes through those 2 points at the focal width and the vertex, I should have a parabola that opens downward, has a vertex of 3, 5, has a focus that is 2 units away from the vertex, and a directrix that is 2 units away from the vertex. That's my p-value. And then that would be how we take the information here and write an equation and sketch a graph. So we should be able to write an equation and sketch a graph given the vertex, given the and the directrix, or given the vertex and the focus, or given the focus and the directrix. There's a lot of different combinations of information we might be given, and the whole idea is if you can find out the direction the graph opens and then your p-value, you should be able to come up with the rest of the information and also write the equation of the graph. So that's the notes for day 2. We will continue to talk about other conics, and some of these vocabulary words will definitely be something we have to know as we move forward.